Welcome, my digital pathology trailblazers. Welcome after a break. I will wait a little bit for you to show up because it always takes a few minutes. But welcome. Whenever you join, let me know in the chat where you're tuning in from. And I see you're joining. This is fantastic. And the topic of today's live stream, today, DigiPath Digest, is making pathologists ready for the new AI era, changes in required competencies. So let me share this with you while you're joining. Come on, why is it not sharing? Okay, give me 1 second and let me know where you're tuning in from. I will be sharing my screen and we should see it right now. Okay. This. Making pathologists ready for the new era of AI, right? Everybody wants to know how to deal with AI and what pathologists actually need to learn. But before we dive into this, I want to give you a few updates because I turned 40, guys. I'm now 40 years old. I officially, because of the age, I consider myself a mid-career pathologist. And at the Digital Diagnostics Summit, I was joined by Giovanni Lujan, and then there was a younger pathologist than us, Dr. Ella Kwama. And we were like, okay, old pathologists, young pathologists. No, we now call them early career, mid-career, and seasoned pathologists. So I consider myself mid-career now because I am 40 years old, which is okay. I wanted to tell you a story from my birthday. So I decided to celebrate with a trip, with travel. So when I turned 30, that was 10 years ago, I didn't have a family yet, and I went for a 3-week trip to Mexico, visited some friends, but mostly traveled on my own. This time it was a family travel. We went to Hawaii, and my husband's gift for my birthday was a surfing lesson. So I go to the surfing lesson, and by the way, let me know where you're tuning in from. I am in Pennsylvania today, so it's 6 a.m. Let me know where you're dialing in from and what time it is for you today. Okay, going back to the story. So I go to the surfing lesson, and there are two other people. They had one instructor. I had another instructor, two guys that were older than me. And I think to myself, oh, how cool would it be to just like get on this board and surf a wave? And then I'm like, this is not how life works, right? Everybody says surfing is difficult, and like just forget about this thought. And then they explain us how to do it, and we go to the water. And I do ride the first wave, and I'm like, but I did crash into the other instructor, so I like couldn't steer. But I did ride the first wave, and then I did ride the second wave, and then like not anymore. Let's say I would ride 50% of the waves, and that made the lesson super fun. But that's not the point of the story. The point of the story is this like riding first wave without any preparation came after, I don't know, several years of snowboarding that did not come easy at all, including concussions and countless falls. At least 2 years of paddleboarding, 2 or 3 attempts, unsuccessful attempts to learn to windsurf, and I don't know what else, like general physical fitness. So all that stuff that I did the years before and resulted in me riding this first wave. So yeah, this overnight success takes like 3 to 5 years or more. So now, of course, I want to become a surfer and maybe a windsurfer or whatever. But just wanted to share this story with you that I did ride the first wave without any preparation. So sometimes there are these moments in life where you have done so much work for something that's parallel, and then you start doing a new thing and it actually works. So that brings me to the topic of our live stream. making pathologists ready for the era of AI. And let me know when you join, let me know where you're dialing in from. So this particular paper is in Modern Pathology. Here. No, come on. Don't give me a hard time. Okay, Modern Pathology, Impact Factor 7.1, and this is group from Radboud University Medical Center. It's a pretty strong group in the computational pathology field with commercial spin-off, ASIN, and taking part in like very important digital pathology initiatives, starting with the Chameleon Challenge several years ago in 2016-17, and now they are big part of the Big Picture initiative. It's a private public consortium in Europe trying to build a huge slide repository. So super strong group, and they decided to check, okay, what do those pathologists actually need to learn right now? So I actually needed to go to the paper because in the abstract, they just tell us that increasing interest in developing and using AI models in pathology, we have this interest, and pathologists generally have positive attitude towards AI, depending who you talk to, but most of the mid-career and early career pathologists do have a positive attitude, but and I've heard that several times. What do we need to learn? They lack the knowledge and skills regarding the use of it in practice, but furthermore, it remains unclear what skills they would require to use AI. Right? So this is not part of the training. This is the reason why I actually created a course of Introduction to AI, like AI Starter Kit. So if you are interested in this course, let me know in the comments. Just write course, and I'm gonna follow up with you about that. So I recognize that as well and prepared a series of videos for you to get started. So because the training of future pathologists and current pathologists is essential for AI use in pathology. So they decided to redefine so-called entrustable professional activities, the EPAs. EPAs, those competencies, they used available academic literature in radiology, another image-based discipline. So this one, that is another image-based discipline. And I see more people are joining. Let me know in the comments. I don't know, maybe the comments are not coming through to my streaming software, because usually you let me know immediately that you're in and where you're dialing in from. So when you're in, let me know in the comments, and I'm going to say hi. So radiology, of course, another discipline that is image-based as well. I mean, there are several, but ophthalmology, and we have seen papers about ophthalmology. Let me just send you a comment. Maybe it's going to unblock the comments. Let's see if it's gonna work. Okay, if you see my comment with just one typo, then let me know. Okay, and I see people liking on Facebook. Fantastic. So radiology, and they say they are more advanced in terms of AI development. I put a question mark here because I recently talked, I mean, maybe they probably took it from the literature, but I recently talked to two radiologists, and I was asking them, hey, what are you doing in AI? Like, what are your applications? And it wasn't that ahead of pathology. The imaging infrastructure, managing images, working with images, accessing images, that was a lot ahead. Okay, we have people joining, and I see your comments. Hi, Monica. Fantastic to have you here. Let me know where you're dialing in from. So radiology, yes, working with images and the image infrastructure and all that stuff, very much ahead of us. I always say 25 years. Hopefully we're closing the gap, but they started 25 years ago, 25 years before us. But AI applications, I couldn't get this information out of those radiologists, meaning they're not using it for those as it's not as prolific as I would assume. Okay, we have people from Brazil. Welcome, Alexander. And we have people joining from Greece. This is amazing. So going back to our topic, and I'm going to just focus on this one because it's important. And it's going to take me some more time than usual. So the most current pathologist EPAs and competences will likely remain relevant when using AI techniques and interpreting and communicating results for individual patient cases. So they looked at the current ones and they propose new EPA to enable pathology training programs to make pathologists fit for the new AI era using AI and diagnostic pathology practices. So this is something that is already widely a lot recognized in the professional societies, communities, in the academic centers. But I think the wheels there turn a little slower. But the more institutions recognize that, the better. There is the European Society of Digital Pathology that has a course. I did my private course on AI. There is a digital pathology course by the National Histotechnician Society. I may be miscalling those organizations, but anyway, there are things here and there. And here in this paper, they showed the competencies. Let me share this with you. It's not working. That's okay. The competencies that pathologists currently need to have. So they need to do autopsies, macroscopic examination, microscopic cytology, frozen sections. Need to have multidisciplinary meetings, scientific education. They need to do quality control of things. They do need to have idea about informatics, system-based practice for informatics. Of course, they need to be professional and they need to communicate well. And here we have this comparison between the Dutch program and the USA College of American Pathologists program, and the ACGME pathology milestones. And what is ACGME? I will need to Google that for you right now because I don't know. And if you know, let me know in the chat. But I want to have this ACGME. ACGME, pathology, medicine. ACGME. This is accredited residency programs in pathology. Prepare residents to acquire these. ACGME. Okay. Accreditation Council for Graduate Medical Education. Now we know, and maybe if you knew it, then that's good. Accredited Council for Graduate Medical Education. So here's what they tell us pathologists need to be able to do. And our authors, which let's name them because I don't think we named them. Szokowos, Connie Hebeba, Megan Milota, Martin Sand, Joanneke Drocht, Katrin Grunberg, and Karin Jongsma. I thought because we're talking about this paper exclusively today, I'll name them. So they have those other competencies. They decided to put together a competency set for technological innovators, something additional to what the pathologists, what the residents need to learn. And role definition, effective use of expertise in the field of technological innovation, that aims to improve accessibility, quality, and affordability of healthcare. And this is for the medical resident. So medical, not just pathology. So what they need to do, those medical residents, and including pathology residents, they need to recognize that medical technologies can contribute to improvement of patient care. And the keyword can. And we're going to see why later. You need to focus on other stuff as well. And they are aware that several steps are needed to bring about change. So implementing changes, this is super important to include it here, because when I was talking to radiologists, one of the concerns of one of the hurdles that they mentioned as one of the main hurdles was change management, especially when you are in a hierarchical way of working, which medicine is a hierarchical way of working. This is caused by the fact that you need several years to gain the experience. So there's not really a shortcut when it comes to experience in patient care. But now you have the younger pathologists, younger doctors who are more aware of the technological changes. So you have a little bit of a clash. So this type of change management was a hurdle when I was talking to the radiologists. Then what they also need to do is assess medical technologies developments for their added value in improving patient care. So this is crucial as well. But they basically say, don't do it for the sake of doing it because it's cool and AI and you're cutting edge. Do it when it actually adds value in improving patient care. So how do you assess that? Well, you need to know enough about the methods that are being used. You need to know enough about the intended use of the particular tool, because what's happening, or what's happening to me when I analyze those technologies. I get to know a new technology. Let's say, I don't know, ChatGPT is fantastic, right? Why are we not using this in medicine? And my initial reaction when this technology is presented to me is enthusiasm. I like those technologies. But then the researcher and the veterinarian, the PhD graduate in me thinks, okay, show me the validation data. How are you going to bring this technology into practice? And I had a conversation yesterday with Hamid Tisush, who is the director of digital pathology, informatics at Mayo Clinic. I'm going to let you know later what his exact position is. But he basically said that this is their motto. Their motto is patient comes first. So he evaluates all he creates new technologies and evaluates all the technologies that come out of different places. And he is he has a similar attitude to me. He's super enthusiastic about new things, but then he very, very critically evaluates them. And then he's a little bit disappointed because few of those technologies that are being promoted actually are useful. Not are useful, are immediately useful to improve patient care. So this particular skill is number 3 here. We need to learn that. And it does not apply only to pathologists. It also applies to, come on, how can I make it big? To everybody working in healthcare, also to vendors trying to bring those technologies into hospitals, into practices, right? So critical appraisal is super important. And then they need to know the limitations of their own knowledge and skills related to medical technology. And knowing one own's limitation, I put the star here because it kind of ties together with the previous one, assessing medical technology. So you need to know the limitations of the technology as well. And by the way, if at any time you have questions, let me know in the comments. I see your comments on I should see them on all the platforms. Sometimes they come with a little bit of a delay, but if you have any questions, related, unrelated, put them into the chat and I'm going to be able to answer them later. And if you're just joining, let me know where you're dialing in from. Let me know your country and what time it is there at the moment. It's 6:20 right here in Pennsylvania, Fairfield, Pennsylvania. So anyway, we need to know the limitations of that technology, and we need to know our limitations. So the digital pathology and all those computational medical specialties, they are very multidisciplinary. They require the cooperation of the medical professional that's the one that's going to be using it. The IT infrastructure is super important. Decision makers, quality assurance, they require quality control. Oh, okay, and I have somebody. I have Guido from Argentina, 8:20. Hello. Okay, so we are 2 hours apart in Argentina, probably depending where in Argentina. So yeah, the medical technology, super interdisciplinary. We have people at polar extremes of expertise, and I'm talking about engineers and doctors. They need to build a bridge, how to communicate, and all these people need to make those bridges to recognize, okay, when do I pass the baton? When do I ask my colleague with a different expertise? And this is not a mindset that is, well, now it should be cultivated, but usually it's not a mindset that you cultivate when you get highly specialized. Like you are in the learner mode at the beginning of your career, and then you are more in the teaching specialist mode. Now those technologies, AI, require to go back, open your mind, and be receptive to others' expertise and recognize who has the expertise that you are lacking. And that brings me to the next point, which is collaboration. Recognize the importance of collaboration with other healthcare, but healthcare is in brackets. So not only healthcare, professionals and companies in the field of technological innovations. So in the healthcare system, I would say we are used to, oh, and we have somebody from Iraq, and it's 2:22 p.m. Fantastic. Marble, welcome. So collaboration, right? And when I started working, so I came out of residency and there were only pathologists, and the one who was there the longest was the smartest, and you would always feel stupid. And then you enter the working world, and you have people with totally different expertise. So now, without changing anything in your expertise, you suddenly feel a lot smarter than you felt just a month ago before you started working, right? But the questions that you get are now totally different questions that the pathologists or those from your expertise would never ask. So now you have to learn how to explain different things. So let me give you an example. I was working with image analysis scientists, and they would perform image analysis on tissue. And then I would look at it and I would say, well, that's not really okay. Here you counted an artifact. Here you analyzed something. And they would ask me, like, but are you sure? It looks the same. Why do you say this looks like necrosis and is not viable tissue? So then I would have to go back to basics. Why is it necrosis? Why does it look like lack of cellular detail, karyorexis, karyolysis, and karyopyknosis? All the attributes of necrotic tissue. Explain it to them and show. And basically teach them, okay, this appearance is a little bit different, totally different questions than what I had before. And that's with all the different expertise. Like engineers are going to get questions from me that they're like, okay, let me, go to the drawing board, baby explanation of engineering concept for the pathologist. But then, with time, we developed a working knowledge of each other's fields. We learned the vocabulary, so you could ask questions, and you recognize, okay, who has the expertise when something specific happens. And here, number 6 is They need to identify opportunities for existing and new technological innovations, and they act accordingly and dare to take responsible risk. This is interesting. So now, because you're going to be, and this quality is called entrepreneurship, now you're going to be working with companies, with startups, with uh, spin-offs, because when a technology is new, it usually gets adopted faster by smaller companies. Maybe not, maybe yes. I think from what I have seen, yes, you will then have spin-offs of research institutions that are trying to productize a particular technology. So then on the medical professional, on the pathologist, there is this responsibility, not responsibility, this expectation of thinking in terms of entrepreneurship, business, how is it going to fit into everything. So these are the new competencies of new medical professionals that are gonna enter that will want to leverage AI. And so let me recap it for you. It's gonna be innovation. Here, we're gonna do this. We're gonna do innovation, implementing changes, critical appraisal, knowing one's own limits, collaboration, and entrepreneurship. Notice that there is no, know how a transformer is designed. No, what is supervised deep learning. Like, there are no specifications of what are the curriculum requirements, and it's going to vary per technology. It's going to be different depending on the tool. So that's why this point number 3 is so important. So this is the new era. A little bit, I see it as a little bit of a different way of thinking. And what's going to happen, I think we can be, what will happen may have something to do with being resistant to decision fatigue. What do I mean by that? Like I mentioned to you at the beginning, there is a new technology, I'm enthusiastic. And then I analyze it and I'm like, okay, it actually only has limited applications to whatever, right? In digital pathology and patient care. Or maybe it has an application for something, but not really something else. So human mind and the decision-making process is kind of binary. You try to say, okay, do I like it or do I not like it? And if you don't like it, you don't explore it anymore. You try to say, okay, do I go with it or not? So if you apply it to a too high level concept, let's say, and if you're confused by what I'm explaining, let me know in the chat. But if you apply this way of decision making, and you have to consciously counteract that, because if you apply it to the whole concept of AI, you'll analyze one tool or one new technology or a few of them, and you're going to say, well, I saw the results, it's not fantastic, I'm not going to bother anymore with it. You're gonna, and we have Sarah from United Arab Emirates. Welcome. What time is it there? So then you're gonna throw the child with the bathwater, and it's easier to do it that way. It's also easy to get scared when somebody is not something is not performing perfectly. And what do I mean here by scared? There is a term called I don't know what the term is called, but I learned it from a podcast guest of mine, from Richard Doughty from Euphoria. I did not publish this podcast yet, but he mentioned something called algorithm scare, like that you see a bad result from an algorithm, like let's say there is a segmentation algorithm for nuclei, and it's 3:30 p.m. in the Emirates. You see a few misclassified cells, and you say, okay, it's not perfect, I'm not going to be looking at it further. And here's where this assessment of medical technological developments come in. So going back to what I was explaining, if you apply the binary simplification of decision-making process to a concept that is too high level, then you're not going to be ready for this technology. And basically any technology. What I started doing is, okay, analyzing everything that I come across. And now I try to think, instead of saying, oh, it's not good enough, I try to think, let's wait till those who are vested in developing this technology are going to make it good enough. Just a file in my head or wherever I'm analyzing these things that, okay, this is the intended use, this is the application, but other applications are not ready yet. Let's wait till it happens. And that happened several times already. Now it's going to be happening even faster. And the example I give is, okay, before you had to do thresholding of positive cells and different things. Now you can use convolutional networks and give examples instead. So a new technology was leveraged to overcome the limitations of what we had before. So if you still have a few minutes, I'm going to let you know just the titles of what else was out there this week for on PubMed, so that you know. And if you decide to read any of those papers, then why is it doing this again? Then go ahead. So, for example, there was a paper about applications of AI in digital pathology for gastric cancer. So if you're interested in gastric cancer, this one is for you. There is one that is focusing on pathology report interpretation and disease diagnosis using fuzzy logic embedded in an AI framework, a new paradigm for digital technologies. I'm gonna look at this one. I want to know what about reporting, what new is there for reporting. Then we have computational staining of CD3, CD20 positive lymphocyte in human tissues with experimental confirmation in a genetically engineered mouse model. Is this about virtual stains? Knowledge-guided deep learning framework to measure the lymphocytic spatial architecture. No, it's not virtual stains. That's okay. And then integrating transcriptomic data and digital pathology for NRG-based prediction of prognosis and therapy response in gastric cancer. Okay, we have some focus on gastric cancer today. Here, transcriptomic data, something that I talked about yesterday with Hamid Tissouche was the multimodality. It's not just going to be learning from images for the new models, for foundation models, or whatever the new models are going to be. It's going to be multimodality. So transcriptomics, radiology images, everything that a doctor would need to interpret results, to make a decision. That's going to be the trend. Or at least that's what he says, will elevate the performance of the current models. So multimodality. Oh, computer vision in digital neuropathology. I need to read this one. This one is on my list for sure. And out of distribution detection in digital pathology, do foundation models bring the end to reconstruction-based approaches? That's also something I want to learn. So out of distribution detection in digital pathology, this is out of distribution is actually when you have a lot of normal and then something looks funky. And if we can detect this, then that is a big milestone, big advancement. And weekly supervised classification of Moss surgical sections using artificial intelligence. So Moss surgery is for basal cell carcinoma, most frequently diagnosed form of skin cancer. And you actually assess intraoperatively whether you have taken everything out. So I'm interested in that one as well, because that's a fantastic candidate for glassless pathology applications. Here they are not talking about glassless, but let's see what they're talking about. And then here we talk about radiology, effectiveness of deep learning model differentiating benign and malignant pulmonary nodules on spiral CT. And oh, interesting, clinical utility of digital dermoscopy image-based AI device in the diagnosis of management of skin cancer by dermatologists. So this is so digital dermoscopy. So this is from the surface of the tissues. It's not histopathology. Interesting. And that's we're back to square one, making pathologists ready for the AI competency. So that is it for today. Thank you so much for joining me. And next week is in the US, we have a holiday. It's Thanksgiving. So we're not going to host the DigiPath Digest, but the week after, I'm going to be back with new papers. So thank you so much. And I talk to you in the next episode.